Hi, in this video discussion, we will be delving into the fundamentals of trigonometry, which is the circular functions. This is now the beginning of the trigonometry, wherein we are trying to locate where do we able to find the sine, cosine, and the tangent in the unit circle. Where did it come from? Okay, so to do that, let us learn and have a review first of the lessons that you had in your junior high school. And I know you're very much familiar with the basics of trigonometry. The SOHCAHTOA. What does S stand for? S, that is sine. C is cosine. The T is the tangent, right? So if you have like the sine, you should have the values of the opposite and the hypotenuse, and that is the sine. But if the given values are only the adjacent and the hypotenuse, then you can use the cosine, and of course the opposite and adjacent are given, then you can use the tangent. In this example, try to examine, diba? We know already in the Pythagorean theorem that the longest side is what we call the hypotenuse, right? And we know that it has an angle. Okay, the angle has an opposite side, which is, we denote it as O, and the adjacent, or in vernacular in Bisaya term, tapad, no, which is A. So that's it. You have opposite side, hypotenuse side, and the adjacent side. So in this case, what do you think are the given values? Do you have the angle, the theta? You don't have the theta. Do you have the opposite side? Yes, you have. You have the O, check. How about the adjacent? Do you have value? You do not have. And the hypotenuse? Yes, of course you have. Therefore, which are we going to use? The TOA, the KA, or the SO? Of course, really obvious. We are going to use the sine. Okay, the sine theta. Theta, or the angle. Opposite over adjacent. Simple as that. Opposite is 40,000 feet, and the the hypotenuse is 10,000 feet. Okay, we are going to see the distance, not the displacement, not the distance from this point, certain point, to the let's say this point wherein it is a little bit parallel, no, to the placement of the airplane. So you have 40,000 over 100,000. You divide that is 0.4. Is this the distance from this point to this point? It doesn't look like it because it is in the 10,000s form, no? But to do that, you need to use your calculator, and you need to press, for example, you already have the answer like 0.4. It's in here. 0.4. Type the answer 0.4 and then press shift. Now there's a shift. You have the shift and then click sine, and that will become sine to the power of -1, and click enter. That answer is 23.6. That is the distance now. Okay, this is the distance of the adjacent, 23.6. Did we got it right? No. This is not the adjacent distance, but this is the angle. I'm sorry. Okay, the angle is 23.6 degrees. Okay. Well, in finding the adjacent, you can use again, you can use the adjacent, so you can use either cosine or tangent. all you need to do is to like use the adjacent is 40,000, like 40,000. Let me use like 40k because I cannot write it that good using this trackpad. And over the hypotenuse is um, hold on, are we using, yeah, we are using the tangent. Suppose we are going to use the tangent, yeah, tangent. That is tangent, okay, tangent. 40,000 divided by the adjacent, which we do not know. We are looking for this, and we know that the theta is already 23.6, right? 23.6. That must be looking like this now. Tangent times 23.6 is equal to 40,000 over the adjacent. So for you to find the excuse me, for you to find the adjacent, you need to multiply it. Multiply it. You can use the let's say, what do you think? What do you call this one? The cross multiplication or whatsoever. Okay, we are going to have an example about this on the next slide. Okay, this one. This is an example of how you can find the the value of this adjacent, diba? This is the adjacent, diba? Let us try to identify. This is the angle, or what we call the theta, right? We have also the opposite. We have the hypotenuse here, the longest side, and the adjacent. Okay. So the question is, what is the height of the tree? So the height of the tree is the adjacent. So we are looking for the adjacent this time. And we know that we need to use the adjacent. It could be this or this. But we are only given the opposite. So this, we are going to use the tangent. Okay? So in trying to identify which to choose, is it the cosine, tangent, or sine, you need to find first the given value and the value which is to be found. So in this case, we know that the theta is 16, so that is now tan times 16 is equal to opposite, which is 14 over x. We are looking for x, no, or the adjacent, right? So how to do that? What we did is just to cross multiply, right? So we cross multiply. Okay, so you have tan, or you can multiply, you can multiply, like you can multiply x over 1 over here and also x over 1 over here, so that it can be cancelled out, right? Or in whichever way you can do that, but it goes like this now, no? X is equal to 14 over let's say tan times 16. Okay, and you multiply it, that is now 14 over tan times 16, and that is now 48.8. So this is now the height of the let's say height of the tree. So again, in this part, you can multiply it by x over 1. You can manipulate it also on the other side, and you can subtract it with, yeah, okay, you can subtract. Let me use it here, you have, again, to make it clear, it's a little bit vague for you, but x times x, that is x, right? And if you multiply on that side, you should multiply it also on the other side. That becomes x times tan times 16. But we are looking for the x, so how to do that? Just also divide it by 16 over here, and the other side also tan 16, right? Cancel this, leaving you with x and 14 over tan times 16. Okay, Okay, sige. So that is just a review of the, let's say, the trigonometric functions that we had last time, that you had in your junior high school. This time we are going to use the circular function. Relate the trigonometric, the triangle inside the circle. Okay, diba? We know that diba, in our pursuit in trying to delve deeper into the conic section circle, we know that we can form a triangle here, right? Using the radius and the Pythagorean theorem. Diba? This is the hypotenuse, which is r, x, and y. And we can use the SOHCAHTOA. Okay, look at this. Diba sine. By the way, the degree can be sine, cosine, or the tangent. So let us first find the sine. Diba? Ang sine is the opposite over a hypotenuse, like that. Opposite over hypotenuse. So what is the opposite of the angle? It is y, right? Let me use the laser. It is y. And the hypotenuse is r. That is y over r. Simple. How about the cosine? The cosine is ka. Try to memorize as SOHCAHTOA. Ka. Adjacent is x, right? Hypotenuse is r. Tangent, opposite over adjacent. Opposite is y, adjacent is x. Tapad. Cosecant is the reciprocal of, let me use an arrow, a pen, so that you will be guided. The sine and the cosecant are reciprocal to each other, while the secant is reciprocal to cosine. It's the secant. So that is now, let me move my camera over here. That is now r over x. So again, and let me just finish this. Okay. Sine, there are three, diba? We know. Sabi natin, sine, opposite over hypotenuse. These are the basic, cosine and tangent. But they also have opposite. Sine, and the opposite of sine is cosecant. The opposite of cosine is secant. No, it lapsed. And the opposite of tangent is the cotangent. Okay, as you can see, look at this. Opposite over hypotenuse. It is now the reciprocal. Hypotenuse over the opposite. How about cosine? Adjacent over hypotenuse. It becomes hypotenuse over adjacent. The same also with their values. It changes. And the tangent, opposite or the reciprocal, is cotangent. Try to take note all of these. And in the deeper sense, we know that in the circular function, it only has one as the radius. 1 unit. From the name itself, unit circle. 1 unit. 1 radius. Only one. Okay? Therefore, we can simplify that the value of x di, or the x-axis, is the cosine, while the value of sine is y. Why is it y? Because diba, we know that the r is equal to 1. This x over 1, or x sine y over r, or y. Or y over x is y over x. How about the second? Try to see, these are opposite, reciprocal. Reciprocal, all of them. Okay, I think I missed something. Hold on. There might be confusion, okay? So hold on. You have because wala siya na-align, no? Let me just erase it, and for you to not be confused rather. So you have this and this and this. Okay, kana. So this one is the reciprocal of second. secant, cosine secant, sine cosecant, tangent cotangent. Does that make sense? Cosine, yeah. Medyo nabali na ko butang, no? But yeah, that is how it looks like. Okay. So why is it not at a 1? Because again, r is equal to 1. Therefore, we can say that the cosecant divided the cosecant is r over y, and we know that the y is equal to sine, right? So it becomes 1 over sine theta. Y becomes sine because they are the same, they are equal. How about this? R over x. What is the value of x? Cosecant theta. So that becomes 1 over cosecant theta. Cosine theta. So you have also another tangent. What is the value of y? Or in this case, this is another trigonometric identity. Diba? Tangent, ang bali sa tangent is cotangent. So that is cotangent theta is equal to 1 over tan theta. Reciprocal siya sa whatever the value of the tangent theta, it is the reciprocal of it. Try to take note all of these. Okay, and this is the the unit circle now. Let us delve deeper how it is done with the set of examples that we are going to have later on. Oh, it's 17 minutes. Okay. Let us try to make this quick. Okay. So you can save this. You can take a screenshot because you will be using this pohon in our next lessons. It's a little bit complicated, but let us try to let's say make it simple. Let us have this example. Example number 1. If sine theta is equal to 8 over 10 in quadrant 1, find the remaining circular functions. Diba, we know that the sine is equal to y over r. Diba, opposite over adjacent. Y over r. You can go back to the previous slides just to check, okay? And in this case, the y is equal to 8 and the r is equal to 10. And the x, we are looking for the value of x. Okay, so to find the value of x, but we know that we use the triangle. If it is triangle, then we can use the Pythagorean theorem like this. Diba, r is the hypotenuse, x squared plus y squared. We do not know the x, right? So we use the Pythagorean theorem. R is equal to 10, y is equal to 8. So 8 squared, that is 64. 10 squared, 100. 100 minus 64, that is 36. Square root of x squared, that is x, and then square root of 36, positive, negative 6. But in this case, we are going to use the absolute value, which is 6. Okay, let us use the absolute value. Okay, so look at this. You have, hold on, you have cosine theta is equal to x over r. Okay, so we are now going to find the different circular functions. Okay, we now have the sine. How about the cosine? So money x over r. X over r is 6 over 10. We substitute the x is 6, r is 10, basing on this function. Okay, let us make this quick. How about the tangent theta, y over x, that is 8 over 6, simplify, divided by 2, that is 4/3, and cosecant theta, that is r over y, r is 10, and y is y is 8. So it's divided by 2. 10 divided by 2, 5. 8 divided by 2, 4. Second, r over x. R is 10. X is 6 divided by 2, 5/3. Cotangent theta, x over y, that is x3. The x is 6 and the y is 8. So divided by 2, 3/4. That's it. Very straightforward. How about in this example, you are given the point, right? Is on the terminal side of the theta. Find the trigonometric functions of this. Okay. Example, the x is equal to -2 because it's in the point here, -2 comma -3. So we have the value of x and y, but we don't have the value of radius. So we are going to solve for that using the basic Pythagorean theorem. So the value of x is -2, -2 squared, that is 4, -3 squared, that is 9, 9 plus 4, that is 13. So the value of radius is equal to square root of 13. You cannot simplify that one, so that's it. And find the sign, that is y over r. So y is -3 and radius is square root of 13. And to simplify that one, just take note, if we have the denominator of a square root of a radical, then we need to multiply it by itself. But it should be a perfect one. So the perfect one looks like this. Square root of 13 over square root of 13, it becomes 1, right? But we need to do this so that we can simplify. So yeah, that is perfect one. That is special property, no? -3 times square root of 13, that is -3 times square root of 13 over 13. Diba? Square root times square root, matangtang, cancel. Or, yeah, may mo na siyang 13. The same ra siya. That is a special property lang, no? Just try to recall your lessons in junior high school about radicals. Cosine x over r. X is 2, basing on this given, and r is 13. The same procedure, multiply it by perfect 1, which is square root of 13 over square root of 13, this 13 here, and that's it. How about the tangent? -3 over -2, but you need to have perfect square, so that is, perfect square, absolute value, so 3 halves. Okay, itango na lang ang negative because that is absolute value. How about this? Square root of 13 over negative square root of 13 over 3, no problem with that because it is not a radical sign, the denominator is not, so no need of multiplying it by perfect 1. How about this? This could be good, and this is already good too. Another example. Okay, let's have this example. It's getting long, but I hope you are still listening. 23 minutes, it's really long. So you have, it's if cosine theta is equal to negative square root of 11 over 5 and cotangent theta is positive, find the values of the other 5 trigonometric functions of theta. Okay, sige. Can you take note of this? Quadrant 1, all circular functions are positive, diba? X comma y positive. Diba ang x na to is, sige, ito yung x na to, the sine, and the y is the cosine. Okay, sige. Let me just again, kada di ay. The sine is y, cosine is x. Take note. Therefore, positive x comma y. Kani pod negative x comma y. So negative sine comma cosine. Kani pod negative. Only tangent and cotangent are positive. Negative to puro ang cosine and sine. Okay, sige. You have cosine theta is equal to x over r, diba? Given this function negative square root of 11 over 5. Okay, x is negative square root of 11 and r is equal to 5. We need to find the value of y. Tulog yun sila kabog x, r, and y. So in finding the y, use the Pythagorean theorem again. You know how to do it naman, no? But I just, let's say, operated it here faster, no? At ato lang manipulate, no? So nahimo siyang minus. So kaya ato mangibalhin ang y. I know you know how to do it. The square root of 5 squared minus square root of 11, negative square root of 11 squared, that must be square root of negative square root of 14. Just to make it fast, no? You can learn this deeper. How about the sign y over r? So y now is square root of 14, negative square root of 14 over 5. That could be good because the denominator is not a radical, then no need of adding perfect 1. So you have x over r. X is negative 11. Okay, negative square root of 11 over 5. That could be good. Tangent y over x, negative square root of 14 over... Okay, this time you need to add a perfect 1, which is negative. Multiply it by square root of 11 over square root of 11. That is a perfect value. So that could be square root of 154 over 11. That's it. Cos secant theta r over y. Radius is 5 and y is square root of 14. So since it is radical denominator, so add perfect 1, square root of negative square root of 14 over negative square root of 14. By the way, it doesn't matter, no? The sign sometimes doesn't matter, but in this case it does, because if the denominator is only negative, and then they are the same naman sad. But of course, since it is like this, diba? Try to imagine lang, diba? Usa ka negative, so that is negative. Kanipod, both the numerator and denominator are negative, so that could, if you're going to divide that one, that becomes positive. That is why we chose square root of 11 positive na siyang duha. Okay, again, kung duha, both numerator denominator positive, pero kung usara, that is negative ang imuhang i-multiply. Understood? Square root of 14 times square root of 14 tang, that is 14, and leaving you with 5 times square root of 14. Kanipod r over x, so denominator is negative, square root of 11, usara, di siya duha, so times negative. That's it. Kanipod x over y, okay, square root of 154. Ano naman yung y? The y is equal to square root of 154. This is cotangent. Diba, we know that the cotangent naa diri na to, no? Diba, reciprocal man is si tangent and cotangent. The tangent value is square root of 154 over 11. So atong gibali na may na siyang 11 over square root of 154. Since it is radical, so atong i-multiply by perfect 1 kani siya, then 11 times this, that is 11 times square root of 154 over 154. Then since there is a greatest common factor between 11 and 154, which is 11, nahimo na siyang square root of 154 divided by 14. A little bit long kaayo, no? But that's how it goes. Good, grabe gyud kaayo siya ka complicated, but more complicated kuan pa puhon, no? Just to add up na lang this quadrantal angle. What is the quadrantal angle? Very quick lang. So you have quadrantal angles is an angle in standard position whose terminal side lies on the x axis or y axis. Look at this. As long as it is on the x-axis, example 90 degree, di ba na siya sa y-axis, You also have 180 degree, diba na siya sa x-axis, and this is 270 degree, this is y-axis. So that is quadrantal angle. Na siya sa quadrantal angle. Okay? Example, be. Diba again, remember cosine theta is x, sine theta is y. Tanaw here. Look at here. X over y. Look at here. Diba 0, 0, 0 is here, 0 degree. So that must be that must be 0 siya. If you are going to multiply it by 180 over pi, diba? Kani pod 90 times 180 over pi, that is pi half. If you can remember, baka ito itong i-convert ang degrees to radian. Kani pod 180 times 180 divided by pi, that is pi. Ay, nabali. That is yeah, that is just pi. Kani po 270 times pi over 180, that is 3 pi over 2. Kani po 360 times 180 times pi over 180, that is 2 pi. Yeah, that's it. So the cosine, di ba ang cosine kay x? So, ang 0 degree, hold on ha. Okay, loading ba? Ayan, you have 1. Di ba? Ang x man di ba cosine is x? So, kara. Kani siya 0. Okay. X, that is cosine. Ang sine niya is 0, of course. Another pod, cosine theta, that is pi half. So pi half is here. Pi half 0, comma to x and y. 0, 1. And so on. You can observe that one and try to look at. You may pause the video and try to see the relationship. Okay. That's it for our lessons about circular functions. We still have more lessons about it, and hopefully you are going to answer the quizzes, the activities which I left for you to answer, and that could be good for our lessons. I'll upload another set of videos in the Links LMS, even though I am going back to in-person next week. See ya. Bye bye.